morning, it's Given from Techno Drive. Today we've got a different kind of job. It's a lithium battery. So this battery is the batteries that you see on solar installations. Yeah, it's a LiFePO4 battery. So this one is a NE-48D100. So this is a 48 volts, and then a 100 amp battery. So it's 100 amp hour battery. So what's happening? When I switch on this battery, the red light stays on. So what's the cause? So this battery was damaged by water. You can see some residuals there. So there's water damage on the battery. So the water went inside the card, because if I turn it like this, you can see the card there. You see this card. This is a BMS card. You see there. So those are the points where the water went in. So it damaged the card. So what we have to do is to change this card. This is a BMS card. You can see there. So this card was water damaged. So the problem we're having here is that we've contacted this supplier, TSE. They don't have the card. So the battery cannot be fixed because of that. So that's a big problem. But there's always a solution. We have to come up with a solution, a better solution. But before I show you the card, let me show you one of the things that other guys do, which is dangerous. Okay, you can see this is the 2 points that connect on the BMS. So these ones, they come from the cells. You see the cells underneath there, and there's a positive from the cells. It goes to the breaker. You can see the breaker there, and then it goes to your output. So this one doesn't go through the BMS. So but the negative goes through the BMS. So there's B minus, and there's P minus, which is the output there. So some other guys, what they do, they just short the output direct to there. So you see now, the output is connected, bypass the BMS, direct to the output there. So this is dangerous. Although you've got a 48 volts, the system will work, but it's not protected at all. So that's very, very dangerous, because you bypass the card. So this BMS is there for a reason. It's there to safeguard the cells, because you can see that there's points. All the cells are connected to the BMS. You can see these cables there. So these are connected to each cell. So the BMS will check if there's an imbalance in voltages, and then it will try and balance the voltages. So if you connect the cell, the battery direct to the output, when you charge, the cell will overcharge. Do not do that. Do not bypass the BMS. BMS is there for the reason. We have to use BMS. That's why even now I can't just connect it directly there, because I've got 48 volts. Let me show you. You will see that I've got 48 volts, but it's not a good thing to do, to bypass the BMS. BMS should be there and should always monitor the cells. Let me bring the meter. You will see. Okay, you can see now I'm connecting my positive lead there, then the negative to one terminal there, which is coming from the cells. You see I've got 49 volts. So if you connect this to the inverter, obviously it's going to come on. But what's going to happen when it's charging? The cell will blast, because they are not connected to a BMS. So we really need the BMS. We've got 49 volts. You can just bypass it, connect it directly to the output without the BMS. But what's going to happen? It's not nice. So the battery will not even last for a month. It will fail. It will fail. It will definitely fail. I think it's four batteries they did that. All of the batteries, the cells were damaged. They blasted. So please, let's not do this. We can't do that. Even myself, I've never done that because I know why the BMS is there, why we have to use BMS. So we have to use BMS. So the BMS that we are going to use is this one. This is the brand new one. It comes with all the cabling. It's got the Bluetooth function. So you can see the wiring. It's a JK BMS. So this is the connection where it connects to the board, the comms port. So this is a brand new BMS card. There it's a new card. This is the card that we are going to use to fix this battery. Okay, let's do that. But the problem now is the connection is not the same. You can see that the cells, this one has got 1, 2, 3, 4 connections. So we are going to rewire it so that it can work flawlessly. Let's do that now. So this is the old BMS. This is the one that has got the water damage. This is a new one. You can see that we've got 1, 2, 3, 4 connections for the cells. This one we've got 1, 2, 3 connections. So the cells were connected there. Although the wiring is it's similar, it's just that they put more pins on each plug on the old one. So these ones they put 4 plugs. So we have to rewire the whole battery so that the connection will be the same. Let's open the cells. Okay, this is how it goes. So this one is cell number 1. So it's B0, this one. B0, B1, B2, and so on. So we have to do the same here. Let's check there. B0, B1, B2, B3, B4, and so on. So it goes in order. So the cable looks like this. Let me get the cable. Okay, here's our first cable. It will go in here. So this one has got B0 up to B4. So this is number 1. So our B0 is this one here. This is B0. This is where we start. So let's do the connection now. So this is our B0. This one is B0. So we are going to cut this one and solder there. Okay, there you can see it's B0 there. So our B0 is there. Let's cut it. I've got the shrink sleeves. So we're going to use this to cover the wiring after soldering. Okay. Let's do it. B0. Okay, there is our B0 there. connected all the cables now. So the last plug is also connected. So that was our number 4. Yeah, that was number 4. So all 15 cells are now connected. You can see all the cabling. So all of the cells are now connected. So we've disconnected these ones. These are the old ones. So we no longer need this. These are the old ones, old plugs. Okay, we are now done with the wiring. Okay, that's it. So one other problem now is the new BMS comes with a switch. There is a soft switch, so we just have to, we can mount it here. So we're gonna mount it here. So I'm just gonna drill a hole here so that we can mount the soft switch. You can switch on with the soft switch or the breaker. So let's drill. Okay. So just be careful when you drill. Make sure that there's something. See, I put a box there so that I can put the dust, because that can damage the BMS. See this box there. So all the shaving fell inside the box there, instead of letting it go to the battery. There we are, we've got our switch in, nice and clean. So now we're going to fit the BMS card. Okay, let's fit the BMS. Okay, the switch is in. And now our cells. So the cables are marked. This one is number 2. So number 2 is this one here. From B0, the number 2 is here. There. This one is number 1. There. This one is number 4. There. And this one is number 3. Okay. And this is B minus. So our B minus is this one. You can see it's written there, B minus. Okay, now our P minus. So our P minus, sorry, our P minus goes straight to the battery terminals where you connect on the outside world. That's where our P minus goes. Let's connect P minus. So our P minus is connected. So what's left is our B plus. This is the cable that supplies the BMS with power. So the old one is here. There. It's connected now. Let's switch it on and see how it goes. There, the battery is coming on. Okay, since I've mentioned that this new BMS, it's upgraded BMS, it has got a whole lot of functions. The other function is the balancing current. This one is it balances at around 1 amp to 2 amps. So when one cell is losing power, it's gonna balance at almost 2 amps. And also it has got a Bluetooth function. Okay, we are now going to test the battery. I've got the inverter connected there on the positive and minus. So once we have enough power, the inverter will come on. You can see now the battery is off. Let's switch on. Okay, the light is red there, but we don't have any output. It's because this is a new card. It has not yet been set. We have to set it so that it can work. Let's open the app. So to get the app, you can scan the QR code from the card. So BMS. Let's open it. You can see on my meter there, I've connected the leads as well. So the voltage that you are seeing there is from the battery. Okay, when you open the app, you will see this list of devices. Let's open it. You can hear the buzzing sound. There we are. You can see that there are some alarms. That's why the battery is not coming on. But since we have connected the cells, you can see all of the cells are there. 15 cells. You can see 16 is not there because it's not connected. I'm sure this is the alarm that's need to be sorted. Let's click and view the alarms. It's saying cell count is not equal to settings. So we have to go and change the cell counts. Let's do that. Setting. You can see that here the cell count is on 16. We have to set 15. Okay, we have to put the password. The default it's let's check I think it's 1 2 3 4 5 6 3 4 5 6, the default. Okay, we have to modify the password so that it doesn't give an alarm. 1 2 3 4 5 6. Let's put the 6 zeros. 1 2 3 4 5 6. 1 2 3 4 5 6. Okay, set password has been set successfully. Okay, let's change the cell count is 15. Okay, so now we have 15 cells. We have to also change the type of lithium of the cells, because these ones they are LiFePO4. So let's click that. Okay, see now it's LiFePO4. Okay, the other settings that we need to do is the control, because you see on my meter I've got 2 volts. The control out is not set. You can see that it's not set to charge, it's not set to anything. So we have to switch on all of these parameters. Let's switch on the charge, switch on the discharge. Emergency heating is not applicable. Disable temperature sensor. So everything is right now. Okay, let's see. But we are not getting an output. We have to check and see why it's not giving an output. Cell count not equal to settings. Let's go again to settings. It means that it didn't take that setting. Cell count. Okay, let's verify the password. Okay, cell count, it didn't say. That's why there's no output there. The inverter is on now. You can see the inverter is on. So the cell count, because we are using 15 cells, so we have to set it to 15. So this is a nice BMS. You can see the settings are very convenient. It's easy to do. Just modify the password. Let's send the live for 4 settings just to make sure. Oh, okay, when we send this live pause settings, it changes the cells to 16. Let's put it back to 15. Then you see it cuts the voltage, so let's put back to 15. Okay, so we've already set to live for 15 cells. Go to control. You can see it changes everything. You can see now the inverter is coming on. So let's go and check the settings, the status. Okay, the status, you just click there. You can see the cells, all of the cells here. You can see. So it's discharging from the inverter, 1 amp. Okay, let's check if it's gonna take charge. Let's connect the inverter to the ESCOM line and check if it's gonna charge. Okay, I've connected the ESCOM line. Let's see what's gonna happen. You can see we are now discharging 0.4. Here the fans are spinning. Now we are charging. You can see we are charging with 15 amps. Very nice. This is a very nice BMS. So it has been set to charge at 15 amps, so it's staying there to 14.7. 100%. So we are done. We have recovered the battery. I'm sure the customer will be happy to see the battery life again. But one thing that I will always advise, do not jump the BMS. BMS is there for the reason. Let's do the right thing. Thank you very much, and thank you for watching.